Hello. So, if you're watching these in order, I apologize that the last video got cut off like that, but we'll continue right on talking about the second derivative. In fact, we'll use an example from the last video to kick things off. So I tried to provide some motivation for the second derivative by looking at a graph, time versus the number of people who have become sick during an epidemic. And I said, well, initially the epidemic is growing out of control, but eventually the epidemic starts to get under control. And I pointed out that when the epidemic was growing out of control, it was increasing concave up. And when it started to get under control, it's increasing concave down. So at this point, where concavity changes, well, that's a turning point in the history of this epidemic. It's important. So, since points where concavity change are important, we, of course, want to be able to find them. We'll give them a name, first of all. We'll call them inflection points. And we'll talk about finding them in this video. Let me give another. I talked about disease, the spread of disease. That was kind of my introductory example. Infection points show up in a lot of real world processes as points of diminishing returns. So, for the economics and business students in the room, this is going to be the most common application that you see. Like, this graph is obviously idealized, but you could look at dollars spent in advertising versus some measure of brand awareness. And you might expect a graph that looks very similar to the disease graph. Initially, when you spend more, you get more brand awareness, but maybe you see a very slow growth. If your budget is super limited, and what's the difference between spending $1,001 versus spending $1,000? There's possibly not a huge difference. But eventually you get into a sweet spot and you start to see a real value for your money as you can now afford more effective advertisement. We have an increasing concave up curve, but at some point, and because I didn't leave myself a lot of space, it's going to happen quite quickly in this graph. At some point, spending more dollars on advertising stops doing much for your brand awareness. Like at some point, if you're advertising on YouTube, and you at some point, maybe everybody who uses YouTube and doesn't use an ad blocker has heard of your brand, and putting more ads on YouTube isn't really doing anything. So maybe you end up with a graph that looks something like this. As I said, very similar to the disease growth graph. And the inflection point where concavity changes is a point of diminishing returns. And that doesn't mean that you shouldn't spend any more money. I mean, if we can make our brand awareness much better than it is at the point of diminishing returns. What it does mean is that, let me give this a name so that I don't have to keep writing a point of diminishing returns. Let me call it C. Prior to C, every additional dollar spent is worth more than the dollar before it. I mean, a little informal, but I hope I'm getting my point across. There might not be a huge difference between $1,001 versus $1,000, but the 1,001st dollar is improving your brand awareness more than the $1,000 did. After C, every additional dollar is worth less than the dollar before it. It doesn't mean you shouldn't spend the money. It doesn't mean you're not getting value for the money. But if C here is $1,000,000, then the million and first dollar is giving you less value than the millionth dollar did. It might still be giving you good value, it's just giving you less value. So this is the big application of inflection points to business and economics. And since I think a lot of students in this class are seeking a degree in that field, I thought we should probably make that explicit in a video. See you soon for a discussion of how to find